Okay, so chapter 5. So up to this point, we've basically only been dealing with one method, and that's been the public static void main method, and that's all we've ever basically dealt with. So what we're going to do at this case is we're now going to um, create our own methods that we can call. So right here on the introduction method, it says methods can be used to break complex programs into small, manageable pieces. So instead of having a bunch of code, a whole big list of code, we might want to break, or we will want to break that code into smaller chunks. And so it's easier to maintain that way. So, so this is kind of what they're showing is we might have public static void main, we get all these statements. Well, instead of having all of our code in one spot, let's break it up into these separate methods. So here's our main method, and we have method 2, we have method 3, method 4, and so on and so forth. So that way there, it's more manageable. It's basically down into these smaller, manageable chunks of code as opposed to this big, long list of code. So, right, so void methods and value returning methods. So we've always seen that void in that public static void main. And what does that mean? The void means nothing is being returned. That says when this method's called, it does something and nothing is being returned from it. We can also call a method and have it return something to us. Okay, so a value returning method is not only performs a task, but it also sends the value back to the code that called it. So, so defining a void method. So we've seen public static void main, and we know what public does. We'll cover static later on, but void means nothing's being passed back, and main says this is the name of this method, and inside the parentheses are the arguments that this particular method utilizes. Okay. Um, so the method modifier is the public and static. So public says anybody can see this. Void is what's being returned from this method. Void means nothing. The method name, and then we got the parentheses. And that's kind of what each one's explained here as far as the method modifiers that I just kind of talked about. Yeah. So how do we call a method? Well, methods have parentheses. We can pass arguments to them. So whenever we call a method, we have to call it. We have to call it by we just type the name of the method with the parentheses on it. That's all we do. We don't write call. We don't do that. We just write the method name and with the parentheses. So let's go ahead and take a look at this simple method program. So we go over here to Eclipse, we expand chapter 5, we expand the source code. We do have a red X, we'll be dealing with that here in a little bit. And let's open up simple method.java. So let's take a look at this. So we've got package chap 5, here's our public class simple method, and here's our public static void main. Now in there I've got system.out println hello from the main method, and then notice down here I've got display message left and right parenthesis. Now the one thing I want you to pay close attention to, you'll notice that what Eclipse does is he italicizes that, and you'll notice this says display message, and down here we have public static void display message. And what does that do? That does a sysout print hello from the display message method. And then it's going to come back to the calling method and execute the very next line. So here's how this works. When we run this, it's going to look for the executable method, public static void main. It's going to print this first sysout, which is hello from the main method. It's going to call display message. It comes down here, and it's going to execute this line, which displays hello from the display message method. And once it hits this brace, this closing brace, it's going to come back to the first executable line past the call, which is line 12, and it's going to display back in the main method. So when we run this, let's watch what happens. And you're going to see this errors exist. That's because this one program up here has got this red X. That's fine. Just click proceed. And look at that. Hello from the main method, which is this guy. Hello from the display message method, which is down here. And then back in the main method. So that's as simple as it gets. That's how we call a method. It calls it, and it comes right back to the calling method. So it executes this line, it executes that, which executes the first line down here. Now there may be more code, and we'll see that later on. There may be more code in this display message. It's going to do all the code in the display message method first, and once it's done, again, once it hits this closing brace right here, it's going to come back and execute the first thing it can after the call, which in this case would be line 12. Any questions on that? Anything? Awesome. So, now another great thing about using a method is we can actually put the call to the method inside of a loop. So, let's open up loopcall.java. And here we've got public static void main, and I've got sysout, hello from the main method. Then I've got a for loop. And remember, the for loop's got three parts. The first part gets executed once at the beginning. The second one is the check. The second part is the check to go, do we go into the method? And the last part is what gets executed at the end of each loop. So we created a variable I. It's an integer. We set it to 0. While I is less than 5, we're going to come in here. We're going to call the display message method. We're going to keep executing that until I is equal to or greater than 5. So it's going to basically go from 0 to 4, which is 5 times. So it's going to call this display message method 5 times. Then once it's done with that loop and it comes back, it's going to then execute that line that says back in the main method. So now when we run this, we see hello from the main method, and then hello from the display message method 1, 2, 3, 4, 5 times, and then it prints back in the main method. So instead of having all of this code from display message inside of this for loop, we just basically call that method, and we just so it's, again, instead of having all that stuff inside of one big main method, we basically put the display message method inside of this for loop. We could have even have taken this for loop and put it down here inside the display message. Okay. Let's open up the creditcard.java. And so here I've got double salary, int credit rating, and string input. You notice up here where you're going to be using a JOption pane. So I got 3 variables. I say inputs equal to JOption pane, show input dialog. What is your annual salary? We're going to take that, because remember, everything that gets out of a JOption pane is a string. We need to convert it to a double and put it into salary. Then I say input, JOption pane, show input dialog. On a scale of 1 through 10, what is your credit rating? 10 is excellent, 1 is very bad. We take that particular item, which is a string, we convert it to an integer, we put that into credit rating. Then we come in here and we say if salary is greater than or equal to 20,000 and credit rating is greater than or equal to 7, we're going to call qualify, which is this method right here, else we're going to call non-qualify, no qualify, which is down here. So if you call qualify, it's going to display a JOption pane, show message dialog, congratulations, you qualify for the credit card. But if that statement is false, it's going to call no qualify, and it's going to display, I'm sorry, you do not qualify for the credit card. So one of these methods will be called, the other one will not, which is perfectly fine. You may have a method that never gets called, depends on the criteria inside of it. So if we run this, it says what is our annual salary? Let's go ahead and type in 35,000, and our credit rating we're going to say is a 5. We click OK. I'm sorry, you do not qualify for the credit card. So let's try it again. Let's run it again. And this time we're going to type in 35,000. And we've got a credit rating of 8 now. We click OK. Congratulations, you qualify for the credit card. So this one here is kind of nice because instead of having all of this code inside of this if statement, we just have a method for when we qualify, and we have a method for when we don't qualify. Now, the one thing I do want to point out is the naming of the methods are very explanatory. They make sense. If the salary is greater than or equal to 20,000, the credit rating is greater than or equal to 7, we're going to qualify. Else we no qualify, meaning we don't qualify for the credit card. So very explanatory type of naming convention for this method really makes it easy to understand. We know just by looking at the name, we kind of know what is going on inside there. So any questions on that? All right. So yep. So what they talk about next is what are called hierarchical method calls. So what this means is we might have a method that calls a method, and then that method might call another method. So we basically kind of go into something, and that goes into something else, and it goes into something else. But you got to realize it's got to come back the same way. So if I call method A, and method A calls method B, and method B calls method C, when C gets done, it's going to come back to B, and then when that method in B gets done, it's going to come back to A. So it basically stair steps down and stair steps back. So let's take a look at deep and deeper. And here it basically says, in our public static void main, we've got sys out, I am starting in main. We call deep. So here's deep, and that says I'm now in deep, and then it calls deeper. And here's deeper, and it says I'm now in deeper. So when this gets done, it's going to come back to the next executable line that called deeper, which is line 25, and it's going to basically just print, now I'm back in deep, and when that method gets done, it's going to come back to line 13, the next executable line of the main, which is after deep. It's going to execute line 13, which says now I'm back in main. So it basically goes here to here to here, back to here, and then back to here. So let's go ahead and run it. Did it run? There we go. And there it is. I'm starting out in main. I'm now in deep. I'm now in deeper. I'm back in deep. I'm back in main. So we kind of see how the hierarchical type of calling happens. When it basically goes to deeper, deeper doesn't come back to main. It has to come back to who called it. It doesn't matter that main called deep. All it knows is deeper call, or deep called deeper. So when it comes back from deeper, it's got to come back to deep. Now, we kind of covered this documentation as self-documenting. Remember how we do a slash asterisk asterisk? Well, we can actually put that kind of stuff into the code for a documentation of a method call, and we'll see how that kind of looks here in a little bit, because they're actually going to do it. Okay, so we've covered calling a method. Well, what if I want to pass something to a method? So we can do that by when we call, now we've seen it up to this point. Like when I call the sysout println, I'm passing this text hello. That's a parameter that is passed to the method println. And then that println actually prints something in the console. When we call the integer class, the parseInt method, we are passing something inside of that parentheses, which passes data to that method. So we've kind of been doing that up to this point. What we want to do now, though, is see how we can actually pass it to a method that we can see. So let's take a look at passarg.java. And there we have so I've got passarg. Here's our public static void main. We've got int x equals 10. And then we go ahead and do this. We do sysout. I am passing the values to display value. So here's display value. Display value passes a number 5, just a primitive 5, a literal 5 we should say. So it's going to come down here, and here, notice now, here's one thing I want you to look at. Inside the parentheses of the receiving method, it's got int num. Notice the int, that 5 right here is an int. If I did 5.0, notice I get a red squiggly line. If I point to it, it says, hey, you better change the method to receive this to something more than int, because it's expecting a double. So anyways, so this display value, we're going to create a new variable called num. And whatever inside the parenthesis up here will be passed to that variable. Okay? And then display value x. So it's going to take whatever's in x and pass that down here to display value. Now here's what display value does with it. It says, it does a sysout println, the value is concatenate num. So it's going to keep printing whatever the value is passed to it. Then it says display value inside the parentheses x times 4. Well, 10 times 4 is 40. Then it says display value integer.parseInt. Notice it's got a string literal 700, which is a string. It's going to convert it to an integer and pass that down here to num. And then sysout println, now I'm back in main. So we should see it display the value is 5, the value is 10, the value is 40, and the value is 700, and then it's going to display it, and now I'm back in main. So it calls the display value method 1, 2, 3, 4 different times, and it passes a different value each time. So let's run it. And there we have, I'm passing the values to display value. The value is 5, the value is 10, the value is 40, the value is 700. Now I'm back in main. So now let's do this. We've got this area rectangle up here. And so let's say we wanted to start. So we just started writing this program. And I've got area rectangle, and I've got double length, width, and area. And down here I've got length is equal to get length, width is equal to get width, and area is equal to length and width, and display data is equal to length, width, and area. Now you notice each one of these guys is a method call. So it's expecting to call a method called getLength, one called getWidth, one called getArea, and one called displayData. Now, here's what's really nice for Eclipse. Here's what Eclipse will do for us. If I hover over this red squiggly line, look what it says. Hey, do you want me to go ahead and create a method called getLength for you? Let's click on it. Watch what happens. Boom. Down here is private static double getLength. And it returns 0. We'd have to code for this now. And then it's got get width. I go ahead and point to that. I'm going to say, yeah, let's go ahead and create method get width. Whoop, look at that. There's our method. And here's get area. I'm going to basically create a method called get area. And look at that. Get area's got a double and a double. And then here's display data, width, length, width, area. I'm going to hover over that. Let's just create that. Boom. And now look at that. It created the display data. Now the one thing it does do, it makes these private, and these really should be public. So when we do hover over that red squiggly line and double click on or click on it, and it creates it for us, we need to come back in here and change these from private to public, but we're just going to leave it alone. Now I'm going to save this, and that red X goes away from the area rectangle. Okay, so that's kind of a nice thing. I can just type in the name of the method I want to call with parentheses, and I get the red squiggly line, and I can hover over that red squiggly line, and I can let Eclipse create the method for me automatically. I just got, yeah, and again, I gotta tweak it a little bit, get rid of this private and change it to public, but that we can deal with that. Now again, remember the difference between private and public is private says only this class can see it. Only this class called area rectangle can see these methods. Nobody else can, which is probably not a bad thing. But when we get into creating our own classes, which I think is chapter 6, is it chapter 6? Yeah, I think it's chapter 6. We get into that, we'll see when there's a point when we do want to make sure we create a private. We need to use the word private. Okay. So that's how we can pass something to a method. Now, the one thing we want to basically we can't do is, like here I've got double D is 1.0, and I've got display value. And display value is expecting an int. I can't pass it a double. It will error, as we just saw in my example just a few seconds ago. Now, but we could do this. I could cast it by doing an int in front of it. So if I did this, and my pass arg, if I had 5.0, I could, in front of the 5, do an int. No, I got to remember how I just did that. Oh, it's just int in parentheses. Oh. So I could do that. And what that will do is that will change that from a double to an int and then pass it down. Now, is that a good thing? No, because what if I had 5.5 here? I got 5.5. That's a double. I'm going to save this. Let's see what happens when I run it. At 5. Because I'm going to make it 5.8 just so I can I'm going to make it 5.9. So 5.9. Now, if that rounded, that would come back as 6, right? But since I'm using a cast, and I'm going to cast it as an integer, watch what happens. It actually just truncates to 0.9. So casting a double to an int is not a good, we never ever want to do that because we will lose data, okay? Most likely. Now, if this is 5.0, that's fine. That's not going to be a problem. But we don't ever know when a double is going to have a decimal place, and if we convert it to an int, it will truncate. It does not round. It will not round. It just truncates. So that's something we kind of want to avoid ever doing. Remember we talked about the big to little? Well, I can make something small, so I can go from an int to a double. That's fine. But going from a double to an int, that's not good. Now, what if we want to pass more than one variable to a method? Well, that's easy to do. We can basically, in this case here, I have show sum. double num1, comma, double num2. Now, when you see this double num1, we're actually created a new variable called num1. And whatever the value is in that calling method, it will pass down the value and put it in this new num1. And I'll get more into this call by value here in just a second. So down here now, sum equals num1 plus num2, and then I'm going to print the sum is sum. So I'm going to pass the doubles, two doubles to this method. It's going to add them together and then display the total. So here I've got show sum 5, comma 10. Down here is show sum. 5 is going to be put into the very first one, and 10 is going to be put into the second one. I create a variable called double sum. I add those two together, and then I display the value. Now it says here, warning, each parameter variable in the parameter list must have a data type listed before its name. A compiler error will occur if the parameter list for the showSum method were defined in the following: double num1, comma num2. It would basically error out because it says I need to know what the data type of num2 is before I can pass anything into it. So in this case, it would be double num1, comma, double num2. Okay, so let's open up pass by value. So here's my main, and I've got an int number equal 99, and it says sysout number is number. Then I'm going to call change me number. And then I'm going to come here and say number is number. So here's my variable number. It's got 99 in it. Down here in change me, I'm passing the value of number to change me. So down here I've got int my value. So 99 gets passed into my value. It says I'm changing the value. My value is equal to 0. We print, now the value is my value. When I come back up here, so down here I changed my value from 99 to 0. When I come back up here, what do you think it's going to print right here where it says number is number? Is it going to print 99 or is it going to print 0? I'm going to tell you, it's going to print 99 because what we are doing is, like I said, we are creating a brand new variable down here called int my value. We are passing the value of number down here. We aren't passing the actual number variable itself. We are just passing the value. That's basically what's getting passed in here. So when I change my value down here and change me, it has no effect on number up here in the calling method. So let's see how that works. Let's run it. Number is 99. I'm changing the value. Now the value is 0. We come back, remember, in the calling method, it never changed. It's still a 99. Right. Well, if I change the number in this class, yeah, that's going to change it. But down here, now, if you're familiar with Visual Basic says I can pass by value and I can pass by reference. So if I pass by reference, I can actually pass the actual variable to that method. So when I do change it, it changes the value of that variable. Java doesn't have that option. Java is always passed by value for primitive data types only. We'll get into strings here in a bit. So Java for primitive data types, it always passes the value only. It never passes the actual variable. If we want to change it, we'd have to receive something back from that method, and we'll talk about that here in a few minutes when we get into that. So yeah, so Java always does pass by value for primitive data types. Yes, so this number can only be changed in this method. When I passed 99 down here, it only passed the number 99 itself. It didn't pass the number variable. The number variable still stayed up here. So let's kind of talk about that. Down here in this method down here, this method cannot see the variable number. And in this method up here, it cannot see the variable my value. They cannot see inside of each other. We can pass stuff to it, but I can't see. So when I'm up here inside the main method, I can't see anything inside of my value. When I'm down here in my value, I can't see anything back up in the main value. I can only see what's in my method right here and now. Does that make sense? Passing object references to a method. So far we've seen examples of methods that accept primitive values as arguments. We can also write methods that accept references to an object as arguments. So let's say, for example, I've got public static void show length, and it's going to receive a string. Now, I just said a few minutes ago, or a few seconds ago, that Java always passes by value for primitive data types. For objects, I remember a string is an object. str right here is an object. It's not a primitive data type. It is an object variable. Now remember, objects have a lot of stuff that comes with it. Remember all the methods that are inside the string class and all the different data and all the different things that come with the object. Well, when we pass an object to a method, we are passing the address of that object to that other method. So we're actually we're not passing the object itself, we're passing the address to it. So when I need to update that object, I'm actually updating the actual object itself. So let's take a look at that. So right here, let's say the string object has Warren in it, okay? And so it says show length name. It's got Warren, and so I call this show length down here, and I pass Warren to it. It's going to say that string, which is Warren, is str.length characters long. So up here in the see, which one is it? Yeah. In the main method, it has a variable called name. Down here in this show length method, it has an str. They're pointed to the same object because again, we are passing the address down here to show length. So the address is pointing to this object, and the str is also pointing to the same object. So think of it this way. Think of it, this object up here has two name tags. It's got a name tag, and it's got an str name tag. So again, when I make changes to the object now, doesn't matter what method I'm in, it's going to make changes to the object in both methods, because again, we're passing the address of it. So let's look at passString.java. So here in my main, I've got string name equals Shakespeare. I go ahead and say in the main, the name is name. Then I call change name, and I'm passing the name object down here. Now, again, what I'm passing is the address of that object. So down here, I'm creating a new object, a new string object called str, and the address of the object up here is being passed down there. I now say string is now equal to Dickens, and I'm going to print in change name, the name is now str. And then we come back up here, it says back in main, the name is name. Now, let's see what happens. Did I say what was true? It says in main, the name is Shakespeare. In change name, the name is now Dickens. Back in main, the name is now Shakespeare. Well, that just kind of goes against what I just said, didn't it? It's like, huh. Well, let's read on. So let's take a look. After line 12 executes, the name variable reference is a string containing Shakespeare. In line 20, the change name is called and the variable is passed to the argument. This passes the address of the string object to the string variable. At this point, both the name and str reference the same object as we saw in that previous figure with the Warren. At first, you might think this statement changes the string object's contents to Dickens. What actually happens is a new string object containing Dickens is created and its address is stored in the str variable. After the statement executes, the name variable and the string parameter variable reference different objects. This is shown in figure 12. So here's what happens. I pass the address. I'm going to actually come up here and let's look at it this way. So right here, I pass the address of name down here to change name. But like I said, it creates a new variable called str. And I think I kind of misled you. It passes the address down here, but what it does is it makes a new copy of that string object down here. Does that make sense? So the actual object isn't really being passed down here, just the address, but it makes a new object from that address. And when we change, so str, just like it says right here, the str and the name are two different objects. Okay, so I think the way I explained it was kind of wrong a few seconds ago. So yeah, it passes the address and then it makes a new object from that address. Any questions? I hope I didn't confuse anybody. So now let's kind of take a look at the documentation, and we can use these things called parm tags, which are short for parameter. So here's what we can do: is we can have this show sum methods displays the sum of two numbers, and it's got at param num1 the first number, at param num2 the second number. And again, since it's the slash asterisk asterisk, that means it's going to be part of the Java doc. And then we put that in front of the show sum. So if I come down here, so this program demonstrates a string arguments can be changed. I've got this change name method as a string argument assigns a str parameter to a new string. I can actually do this. I can do at str name passed to method. So I'm going to save that, and I'm going to come up here to project. I'm going to click on generate Java doc, and I'm going to go ahead and click finish. And it's down here, it's constructing all the Java doc stuff. I think it's done. So now when I come over here to my workspace and I go to chapter 5, I now have a doc folder. I double click on that and I open up the index.html. And there's my module chapter 5. Here's my package. Here's my pass string. Here's my class. Okay, I'm going to click on the pass string. Look at it. So here it is. This program demonstrates the string arguments cannot be changed. Where did that come from? Ah, this program demonstrates the string arguments can't be changed. Here I've got, look at that, here's my two methods. I've got change name and I've got main. It gets a string str passed in. Let me kind of, down here, look at this. It says, this change name method accepts the string arguments and assigns its string str parameter to a new string. And where's my param? Where did that show up? Oh, come on, don't make me a liar. It should have put that parameter in here. Huh. Yeah, it should have put that param in here. Yep. Well, so you're going to make a liar. So it made a liar out of me. Yeah. Well, anyways, I don't know why it's not working. Field, there's constructors, method. And anyways, but you kind of get the gist. So yeah, so it's apparently supposed to be self-documenting, but it doesn't look like it's doing a good of a job. Okay. Yeah, it should have showed something like this. It should have showed parameters, num1, num2, first and second. I don't know why it didn't do that. So let's talk about local variables. Okay, we've talked about variables. Let's talk about what we use the term local variables. So local variable is declared inside of a method and is not accessible to anything outside of that method. So let's open up localvars.java. And so here I've got, in my public static void main, I've just got two calls to two different methods. I've got Texas and California. I'm not passing anything to either one. When I call Texas, I've got int birds equals 5,000. And it says in Texas there are birds. So whatever's in that variable, birds. When I call California, I create another variable called int birds, and it's got 3,500. In California, there are birds. So the whole point of this example is this. This is a local variable inside of Texas, int birds. That guy is born right here on line 21. It is born and got data put into it. It dies right here at that closing brace. It's basically, boom, done. This int birds is a completely different variable. It is born right here on line 32, and it dies right here on line 36. When we talked about the garbage collection, so what it does is it basically just kind of says, okay, I'm not using it anymore, and it's still sitting there in memory, but the compiler can't see it anymore. And again, when that garbage collection process runs, it will clean all that up. It cleans all that up for us automatically. But just realize this is a local variable that only Texas can see, this birds. And down here, this birds is a local variable that only California can see. No other method outside of here can see this. Does that make sense? So even though they have the same exact name, they have the same exact data type, again, It's born right here on line 21 and it dies right here on line 25. Down here it's born on line 32 and it dies right here on line 36. Okay. Okay. Yeah, it talks about the local variable's lifetime. I just talked about that. It's born right there on that line where we basically gets declared, and it dies when that method basically at the end of that method. Yep, it's a life or death situation. It's born and dies. It's got a very short lifespan, nanoseconds. Yeah, same way with these two variables. These variables right here are double num and double num1 and double num2. They are born right here and they die right here. So you can kind of consider these local variables as well. Double num1 and double num2. Just kind of a warning right here. It says local variables are not automatically initialized with a default value. They must be given a value before they can be used. If you attempt to use a local variable before it's be given a value, a compiler error will result. So for example, I've got my method, I've got I've got int x, and down here I got sysout x. It says right now x has no value. Right now it's got a null. Remember when we create a variable, a primitive data type, it defaults to a null value, which is a binary all zeros, and the compiler can't deal with null, so it would basically it would blow up on this sysout statement. Okay, so at this point we've basically been calling methods and we've been passing stuff to a method. How do I get something back from a method? So right here I see we've kind of dealt with this so far. For example, when we do an integer.parseInt 700, it passes this string literal 700 to the parseInt method. It converts it to numeric, and look at this, it passes it back and puts it into num. So this guy returns something from this parseInt. Same way with the math.pow. The pow it creates exponents. In this case, it raises 4 to the second power. So how do we define a value returning? Well, if we take a look at this statement here, I got public static int. Up to this point, all we've seen is void. Now I've got an actual int in there. What that says is, this method is going to return an int data type. Okay? So if there's something other than void right here, we better have a return statement. See, it's got return down here. So this int says I'm returning an int. Better see the word return down here. If you don't, it's going to error. This is getting past int num1 and int num2. We create a local variable called int result, and result is equal to num1 plus num2. And then it's going to return the result, which is an int. So that is the return type. Let's take a look at returnvalue.java. Do we have a returnvalue.java? No, we do not. I'm using a previous value. See. Well, I got return value. Wow. How the heck did that happen? I got to make sure I get that updated. Oh, value return. It's called value return. My bad. Value return. Yeah. Apparently, I got a little dyslexic there for a second. Okay, so we got value return. Here's our public static void main. I've got int total, value equals 20, and value 2 equals 40. And I'm going to say total is equal to sum. Notice the sum is italicized. That tells us right away that's a method. And we're passing value 1 and value 2. So we come down here, and here is int num1, int num2. It's got int result. That's a local variable. Only this sum can see. Now you notice in the public static it says int. It says I'm returning an int value. Down here you notice I've got return. Now watch this. If I were to comment that out, watch what happens. We see a red squiggly line here. It says, hey, you better add a return statement because I see an int right here. So, and if I change this to a void, down here, notice it says, you better change the method return to type int because it's expecting to return an integer value. So again, those two always go hand in hand. Whatever data type is up here, you better have a return statement for it down here. Okay, so we've passed num1 and num2. Now notice, this is value 1, this is value 2. I could actually change these. I could change this to value 1. I could use the same exact variable name, but if you remember, it's still passing by value. It's not passing by reference. So I got a local variable called result. It's an integer data type. Result is equal to num1 plus num2. Then I return the result. And then now to pass it back, I have to have something equal to that method. In this case, I've got total is equal to the sum method because something has to be able to catch what's being returned. And the way we do that is we say some variable is equal to that method. So whatever this result equals num1 plus num2, it gets passed back, that will be put into total. And then we display the sum of value 1 and value 2 is total. So let's run it. The sum of 20 and 40 is 60. Pretty cool stuff. Now, you'll notice that this guy has this param1, param num2, and a return statement. Let's see, did that give us what we need? So I go to package. Here's my pass string. Maybe I got to rerun it. Let me try rerunning it. So I'm going to do a generate Java doc. Okay. Go to package, and there's return value. Let's see, did that give us? Look. Yep, there it is. Look at that. Okay. So down here, notice it's got public static int num1. It's got parameters, num1, the first number to be added, num2, the second number to be added, and it returns the sum of num1 and num2. So when we look over here, num1, the first, so here's the sum method returns the sum of its two parameters, param num1, param num2, and return. And if we take a look, parameters, num1, and returns. So if you kind of look here, if you kind of look, really what all this at parm, and at return is doing is it's kind of making these like bulleted items where this parameters is bolded. See, and do you see the word parameters anywhere? No, because it's associated with this @param, and @return. That basically, so it automatically creates this word parameters and this word returns. So that worked. I don't know why the first one did not work. That kind of wild, but so as we add more self-documenting code in here, we will basically get more down here. We can actually put a lot of notes in here. And again, this is for the person that comes behind us to basically update this code. They're going to come to this documentation to kind of see how everything is kind of laid out. Let's do this. Okay, so I think the next program, yeah, so it talked about the return tag. Is this in the spotlight? So it says your friend Michael runs a catering company. Some of the ingredients that his recipes require are measured in cups. When he goes to the grocery store to buy those ingredients, however, they are only sold by the fluid ounce. He's asked you to write a simple program that converts cups to fluid ounces. So we need to design the following algorithm. We need to get the number of cups from the user. We need to convert the number of cups to fluid ounces, and then we need to display the results. Page 297. So we need to have a method called getCups, another method called cups to ounces, and another method called display results. So let's open up Cup Converter, and notice we're using a JOption pane up here, so we're doing the import. So here I've got double cups and double ounces, and cups is going to be equal to getCups. Notice we're not passing anything to the cups, but notice we've got an equal sign, so that there better be a return statement. There has to be a return statement in the getCups so we can put it into this variable cups. So here's getCups. We have two local variables, string input and double num cups. I've got input, JOption pane, show input dialog. This program converts measurements and cups to fluid ounces. For your reference, the formula is 1 cup equals 8 fluid ounces. Enter the number of cups. Okay, so we take the input, we convert it to a double, we put it into num cups, and then we return num cups. And so now cups, on line 17, cups will now have data in it. Then we're going to say ounces equals cups to ounces, and we're going to pass cups to it. But since I've got the ounces equal, there better be a return statement. So I come down here and I see there's cups to ounces. Notice that it's returning a double. And it's receiving a double. And look at this. This is how simple as it gets. Num cups, it returns num cups times 8.0. Then, so now I've got num cups. Or I got ounces now. Then I say display results. I'm going to pass cups and ounces to it. Now notice I don't have an equal sign in front of this method, so there's not going to be any return statement there. So here's my display results. I'm receiving double cups and double ounces. I'm doing a JOption pane.show message dialog. Cups equals ounces, fluid ounces. So we might have 8 cups equals how many fluid ounces. So let's run it. And here is our program. So it says, this program converts measurements in cups to fluid ounces. For your reference, the formula is 1 cup equals 8 fluid ounces. So let's say we had 4 cups. Click OK. And 4 cups is equal to 32 fluid ounces. Let's run it again. And this time we had 5.5 cups. Click OK, and it says 5.5 cups equals 44.0 fluid ounces. So a lot going on there. So this first method call is to get the number of cups. So we're asking the user to give us a number. The second one, it just converts cups to ounces. And then the last one displays everything. So this middle one really doesn't do anything that we can see. It does all the calculations basically. So pretty cool stuff, correct? So, yep, that's the whole point of programming, is let it do the work for you. You know, think about all the software you've used, or even the websites where you type something in and it does all these calculations or whatever and gives you data back. Think about this type of a program be working behind the scenes, and that's basically what's going on. Yeah, exactly. You type stuff in, and it takes all that stuff and creates all of those different tones or whatever the case may be. How that all works blows my mind. Okay, let's open up return string. So at this point, we've kind of been dealing with primitive data types. So well, talks about returning a Boolean variable, and again, Boolean is a primitive data type. So here I've got public static Boolean is valid int number. So we're passing an integer. It's going to be called number. And since I see Boolean right here, we better be returning a Boolean data type. So here I've got Boolean status. If number is greater than or equal to 1 and number is less than or equal to 100, we're going to say status is true, else we're going to say status is false, and then we're going to return status. Now, the one thing I do want to point out here is the really good name of this method. Because look how we're using that method. So I got int value equals 20. It says if is valid, and we're going to pass value to it. That's kind of a cool. That's kind of a cool way to use it inside this if statement. If is valid, we're going to print. So if that comes back as true, the value is within the range. Else, the value is out of range. So let's return a reference to an object. So this program demonstrates a method that returns a reference to a string object. So, and this works just like the call, except kind of in reverse. Let's kind of talk about it. So let's open up returnstring.java. So here I've got my public static void main. Here's my string customer name. Customer name is equal to full name John, comma, Martin. So we're passing two string data types. And then we're going to print customer name. So we come down here. Now notice we're passing two strings, but we're getting one string back. So let's see what it does. So down here it's got public static string. So it's got a string right here. That means it's expecting a return statement, and it's going to return a string. I've got full name is the name of the method, and then string first and string last. What do we call it up here? We called it, well, John and Martin. So we create a local variable called name, and name is equal to first, concatenate space, concatenate last. So really all we're doing is taking the two names, joining them together with the space to make it a full name, and then we return name. And then we basically print the customer name, which in this case should print John space Martin. So let's run it, see what happens. And sure enough, there's John space Martin. Now, let's take a look at this next one, because that was a string literal. That really wasn't a string object per se, because it was a string literal John and Martin at the double quotes. So, well, let's do this. You don't have to do this. You just watch me. But I'm going to say string f name is equal to John, and string L name is equal to Martin. So now I'm going to change this to F name, and this is going to be L name. Oh. Okay, so now what's going to happen here is it's going to pass the address down here to first, and then we're going to create a new variable called first, and it's going to be string data type, and it's going to use that address to basically copy everything from that variable f name into first. It's going to do the same thing with L name. It's going to pass the address down here, and it's going to create a brand new variable called last, and it's going to get all that data from what's in the address. And so, kind of like I said, just like the other way, except in reverse, it does pass the address, but it still creates a new variable, a new string variable object. Okay, so this is problem solving with methods. What page is that on? Page 302. It says large complex problems can be solved a piece at a time by methods. At the beginning of this chapter, we introduced the idea of a divide and conquer problem. So let's take a look at the example. Program code listing 512 reads 30 days of sale amount from a file. Okay, so we are going to need to copy some files in. So let's do this. Shoot, I meant to fix that. So let's open up sales report. Let's open up sales report. And since we're going to be doing a read, notice we've got a throws IO exception in there. Because whenever we have to have that whenever we do a read or a write. So here's our class sales report. Here's our public static void main. Notice we got the throws IO exception. I create a constant called num days. It's an integer. It's got the number 30 in it. I've got string file name. I've got double total sales. I've got double average sales. So I've got my three variables there and my one constant. And then I'm going to say file name is equal to get file name. And here's get file name. It's got a local variable called file. It's a string data type. It's going to use a JOption pane to say enter the name of the file containing 30 days of sales amounts. We put that into file. That's already a string, so that's good. Then we return that file, and that's going to be put into file name. And then total sales is equal to total sales, and we're going to pass the file name to that. So we take and look at it. It's got equals, so we better have a return statement. So here's get total sales. We got the file name. Notice we have the throws IO exception. We have to include that since it's doing a read. We've got double total equals 0.0. We've got double sales. Here we create our file object. So we got file, lowercase f file equal to new file name. So that gets the file, and then scanner input file equals new scanner file. That opens the file up for read. Remember, while we have the while statement, and it says while input file has next. That means it's whenever we open up that file, it's looking at it's pointing at a record, and it's saying, do I see a record there? That's what has next says. Is there a record? If there is, we're going to come in, we're going to say sales equal input file dot next double. So it's going to read that line and put it into sales. We're going to say total equals as plus equals sales. We're going to add sales to total. We're going to come back up here and see, is there another record? If there is, we're going to keep reading that record right here on line 81. We're going to put it into sales, and we're going to keep adding sales to total. We're going to keep doing that until there's no more records. We're going to close the file, and then we're going to return total. So that guy gets done. Total sales now has the total that was basically reading each one of those records. Then we're going to create a variable average sale, or it's already been created. We're going to load the average sales variable, and that's equal to total sales divided by num days, which is 30. Then, once we got all of that data, we're going to be called display results. We're going to pass total sales. We're going to pass average sales. So all the way here at the bottom, here's display results. Notice it's got a void. It's returning nothing. We're bringing a double total, a double AVG. We come in here, we're going to create a decimal format dollar object, and we want a comma separator rounded to 2 decimal places. We're going to use a JAption pane.show message dialog. The total sales for the period is $dollar.format total. So it's going to use a 1,000 separator and then basically round to 2 decimal places. Notice we got a new line. The average daily sales were $dollar.format AVG. So let's run this guy. And it's called, thank you, monthly sales.txt. I click OK, and look at that. The total sales for the period were 56,437.42. The average daily sales were 1,881.25. Right, you have to put it, so you have to go to Workspace, go to your Workspace, double click on Chapter 5, and just place it right there. So it didn't work for you?